Hi everyone. So, here we are back again in this 8th week discussing about the sludge management part. So, in the previous lecture we had a basic introduction of the sludge produced in the wastewater treatment facility. So, from which different units it could be produced, okay, and what are the some of the attributes related to the sludge production, what is the primary sludge, secondary sludge, okay, and what are the different stages in which the sludge remains or sludge is processed throughout the wastewater treatment facilities. This class we are going to talk about the characteristic of the sludge. Okay. So, how this sludge is characterized, not the procedure, but the parameters based on which the sludge is characterized, and what are the typical characteristic of the sludge coming from the different steps or different unit processes or unit operations from a wastewater treatment facility, and we will talk about the quantitative aspect of the sludge generation. So, how much sludge can be produced from the different units or those kind of different aspects. So, to begin with, if we see the characteristic of the primary sludge. So, although as we said that the primary sludge basically comes from the your preliminary your primary settling tank, okay, but then all the kind of inert or non biological sludge, those kind of thing are also can be included in the primary sludge. So, if we see the based on the source of the sludge, so if it is coming from the screening, so screening sludge includes all type of organic, inorganic materials which are large enough to be removed from the bar racks. That is how they are removed. Okay. So, the organic content varies because we never know what is coming in the floating, whether they are leaf, there are cloths, there are wood pieces, okay, or there are polythenes, or there are say paper, those kind of thing. There could be various non-organic stuff as well. Okay. You are coming, let us say iron rod is coming, aluminum sheet is floating through that. So, some metal, those kind of thing. So, it totally depends on the nature of the system and the season of the year also. Okay. So, in monsoon we will say lot of things actually go into the drains, wastewater drains also. So, they will have much larger portion of the screens coming in, okay, which are removed through the screening. So, characteristic can also change from place to place, how nice the wastewater system is. If you have, let us say, your sewerage system for collecting of the sewage is covered from the top, there is no kind of additional or foreign materials venturing into the sewer lines, then you will see lesser of these screens, and the characteristic of screens would typically be whatever is being generated or being flowed from the household scale. But if you have a open drain system, so there is lot of things, wrappers, polythene, various tree leaves, all those things actually go into there, and that can actually change the composition and quantity of these screens. The grit is the second system which kind of generates some sludge. So, grit is usually made of heavier inorganic solids, okay, which settle with relatively high velocity, and depending on the operating conditions it may contain significant amount of organic matter also, but generally it may contain some significant organic matter, but mostly it contains the inert grit material or those kind of thing. Okay. It may contain fats and grease also, depending on the like the material which is being removed, whether it is of that type. So, because grease and these things also can actually be removed in the grit chamber. So, they can also come under that setup, but very little. Okay. They are since relatively like if there are large clumps of grease and those things, they can probably be settled, but mostly like majority of the fats or oils and those kind of things are lighter than the water, so they do not settle in the grit chamber. So, very little composition could be of this, but majority will be inert grit materials. Then we have scum removal or grease removal systems. Okay. So, in a primary sedimentation in a preliminary treatment when we are discussing. So, it is not that common for the sewage treatment facilities, but for many of industrial treatment these things. So, there is, if your wastewater is containing lot of oil or grease or those kind of thing. So, what happens that grit removes the heavier particle, but these things float on the top. So, there is a scum removal or grease removal unit can also be given, which kind of makes it so that these things come into the top of the tank, and then from there they are removed as scum. So, that is called scum removal or grease removal. So, this consists of basically floatable material which is skimmed from the surface, okay, and this we may not always go for a separate unit, because this can be done in a primary sedimentation as well. Okay. So, then again this may contain grease, this may contain vegetable oil, mineral oil, animal fats, these waxes, soaps. So, whatever is the lighter material which actually floats, which does not settle down, but instead of, because if it's having a specific gravity which is say lower than the water, so then instead of settling it down, it will flow on the surface. So, all those things which can actually float on the surface of the water, they are removed in these scum or grease removal systems, okay, which actually can come from primary sedimentation as well. But the difference is, let us say if you have a primary sedimentation basin, okay, so the primary sludge will be collected from the bottom, which is being basically driven by this thing, whereas scum and this thing will be collected from the top. So, when you allow it for some time, the particles, the heavier particles, these sediments or settleable solids, they settle down, and those lighter particles, they may come on to the top. So, the removal could be from both sides. From top we can remove these scums or grease or floating materials, and from bottom we can actually remove the settled materials. Okay. So, the primary sludge, which is one of the major constituents as we were just discussing. So, this primary sludge again consists of usually kind of like the settleable solids. Okay. So, these solids which come in primary sludge usually grey and slimy, okay, and in most cases has some offensive odor as well. So, this can be readily digested under suitable conditions of operation, okay, depending on again what kind of this thing. Many times like the primary sludge may contain significant amount of organic compound, but there might be possibility if there are very fine solids, inorganic solids which are not removed in the grit chamber, even with the higher specific gravity, they will also settle in the primary sludge. So, the characteristic can vary again depending on the source, depending on the climate, depending on the region, depending on the living habitat of the people. So, all these things will eventually govern the characteristic over there. There could be sludge coming from the chemical precipitation approaches. So, particularly like though not so used in the traditional municipal wastewater system, but many of the industrial system it is used. So, if you have let us say various dissolved heavy metals or those kind of things, so you can basically one can go for chemical precipitation of those heavy metals by adding lime, adjusting pH and those kind of things. So, there would be lime sludge which will be produced, okay, because this chemical precipitation is mostly done by changing alkalinity. So, like this which contains iron metals such as iron and those kind of thing. So, we can add the chemical, particularly lime, whatsoever is in the form, and that allows the various hydrates of iron and aluminum and various other metals to settle. Okay. Now, this material which settles could be gelatinous, okay, and particularly with addition of lime or those kind of thing, we can actually form gypsum in this thing. Okay. So, these things also can settle, and its quantity again be depending on the dose of the chemical which is being added and the amount of metals which are being precipitated. Okay. So, what is the TDS of the system? There are how many dissolved metals and those kind of thing. So, they can be removed, okay, for the purpose. Many times these chemical precipitation methods is used in the industrial wastewater treatment facilities, and in sewage what happens that for a smaller portion, if it is intended to be reused and there are issues related to the kind of characteristic or metal, higher metal concentration. So, the treated sewage from the secondary units could be processed for chemical precipitation as an advanced treatment unit as well at times, okay, for those part of the water which is going under some sort of reuse. Okay. So, that is the another type of sludge which is generated. Then if we see the characteristic of the secondary sludge, okay, the secondary sludge which is most part comes from the activated sludge process. So, activated sludge process generally has a brown flocculent appearance, okay, because the bacteria which gets accumulate, they form flocks also. So, that kind of thing is, if the color is dark, the sludge may be approaching to a septic conditions. So, that means if the color is turning darker side or blackish, there is possibility that there is not enough oxygen available and the sludge is turned, or the conditions are turning anoxic, and that way sludge is turning septic. Okay. If the color is lighter than the usual, that may have been kind of like under that may have been under aeration with a tendency of the solids to settle slowly. So, sludge is good condition, have inoffensive earthy odor. So, like the odor which will be coming from the sludge will not be very offensive, will not be like very strong odor or something, it will be kind of like this, the smell of kind of a soil or kind of a earth. Okay. So, not much smell comes from the activated sludge that way. The sludge tends to become septic readily, and then that is why kind of may have a disagreeable odor for purification. This activated sludge will digest readily alone when mixed with the primary sludge. Okay. So, there is a good possibility of digestion of this activated sludge. The trickling filter sludge again is kind of brownish, flocculent, and relatively kind of not so offensive smell, okay, when fresh. Its process is same, it is the like in trickling filter or in activated sludge process, the material the sludge is produced from the aerobic decomposition of organic matter. So, kind of characteristic again more or less remains same, okay, and this also can be digested readily. The aerobically digested biosolids, which are the sludge which has been digested once. So, as we were saying in the previous class, there are different stages of sludge. So, the digested biosolids are generally brown to dark brown. Okay. So, the digestion has taken place. We will talk about the digestion process in the later this thing, but like once it is digested, its color can have like this way. The odor of aerobically digested sludge is also not offensive, okay, and it is often characterized as musty. The well digested aerobic sludge will kind of like dewater pretty easily in the drying beds. Then there are anaerobically digested biosolids. So, when we digest the biosolids anaerobically, which is actually the probably one of the more popular approaches for digestion of the sludge. Okay. So, this will be kind of in a dark brown or black, okay, because it is done in a anaerobic condition, so septic conditions, okay, and then there is may contain a large quantity of gas in it. Okay. Anaerobic processes are done in a closed system in order to prevent from oxygen, and there is a gas production as well, as we discussed in the previous class. So, previous week. So, there is methane or those kind of biogas generation is there, and if it is not taken out well, so there might be some quantity of gas present in there, and that may lead to some sort of odor as well. So, when it is properly digested, okay, there will not be like much offensive odor, okay, but like if it is not properly digested, then there might be problem of such order which is being relatively faint, like the order of hot tar, burnt rubber, or this kind of waxes. The primary sludge, when anaerobically digested, produces about twice as much methane gas as does the waste activated sludge. Because waste activated sludge, the majority of the organic matter has already been decomposed once, half of that has already been converted to CO2 or those kind of thing. So, that way the potential for methane production is not that high, and in fact the primary sludge have much higher the methane production potential that way. When drawn off onto the like porous bed of thin layers, these solids are first carried out by the surface and then eventually the drying place. Okay. And as the dry solid, when the gas escapes, this leaves a well rocked surface with an order resembling that of the garden loam soil. Then there are compost. Okay. So, composted is this sludge can be composted, which becomes another layer, and composted solids again are dark brown to black, okay, but color may vary depending on the kind of bulking agent and the composting process itself. And the odor of the well composted solids is also inoffensive and resembles basically garden type soil conditioners. Okay. So, that is the basic characteristic of the secondary sludge, or primarily the secondary sludge is this much though, but then the digested sludge also can be included in there, right. If we see the chemical composition of sludge, so chemical composition of sludge would again be depending on we are talking about which sludge. So, this is untreated primary sludge will have total solids of the order of 5 to 6%, the typical value is 6%. Okay. The volatile solids is 65%. Okay. The grease and fat is typically not there, very little. Okay. The proteins is almost 25% of the total solids, then nitrogen, phosphorus, potash. So, these are the like nutrients, essential nutrients for plant growth or fertilizing components are there in the untreated primary sludge. There could be as high as 10% of cellulose around that, okay, range is 8 to 15. There might be little iron, then pH is typically from 5 to 8 with an average value, typical value of around 6. So, alkalinity, organic acids, and kind of energy content in kilojoule is of the order of 25,000 or so. Okay. So, that is untreated primary sludge. If we see the digested primary sludge, so after digestion the dry solid may reduce, the volatile solid is 14%, there might be some soluble fats and those kind of things coming into the system, then protein reduces, the digestion actually increases the fertilizing component. So, those solids will be converted to nitrogen, phosphorus, those kind of things. So, these concentrations increases that way as opposed to the undigested sludge if we see. Okay. Many things more or less remain same though, okay, and we will lose onto the there might be like increase in the alkalinity, okay, and we may lose organic acid front because organic acids are digested that way, and the energy content of the sludge will also reduce because we are reducing the organic mass from the this thing, and part of this is escaping as a gas or those kind of things. So, that is why the digested sludge will have lesser energy potential. If you see the activated sludge, so the dry solids is very little of the order of like 0.8 to 1.2% just, okay. The volatile solids may be quite high, okay, and that way we will have like various other things, the proteins and the organic constituents quite high. There is not much of cellulose, iron and those kind of thing in there, and if we see the pH is around 6.5 to 8, and alkalinity around 580 to 1100 is the range that way. So, these are the kind of chemical compositions of the sludge from primary and secondary systems, okay, primary and secondary units which produces sludge. If we look at the quantitative aspect of the sludge, so the sludge generation again depending on the different units we will have the different range of the production of the sludge. So, if we see in kg per 1000 meter cube, so particularly the dry solids, so the primary sedimentation produces at around 150, the range is 110 to 170, but typically produces 150 kg per 1000 meter cube of the wastewater treated that way, and the specific gravity is typically 1.8. The activated sludge, which is your waste biosolids, are again of the order of 70 to 100 with a typical value of 80 kg per 1000 meter cube. The trickling filter 60 to 100 with an average value of 70 kg per 1000 meter cube. Then there are extended aeration or these lagoons, so they also produce this sludge in a little higher concentrations because the aeration period is extended. So, more solids, more dissolved organic converts into the solid, and that is why we in order to have higher efficiency there would be larger sludge production as well. Through typical filtration or algal removal process very little. Then we have the processes when we add chemical for the phosphorus removal or those kind of thing. So, depending on the lime addition, depending on the doses of lime we are adding. So, if we are adding high lime doses or low lime doses, we will generate significant amount of sludge. This sludge is primarily because of chemical addition and not because of the constituents which are already present in the water, because we are adding significant amount of constituents in the water. So, they produce here as a sludge. Okay. So, for say if we are adding 500 milligram per liter of the lime, okay. So, 500 milligram per liter, that means 0.5 gram per liter or say 0.5 kg per meter cube that way. Okay. So, that means for 1000 meter cubes the 500 eventually will come from there itself. Okay. So, that way the amount of solids generated, dry solids generated is quite high. Okay. And then denitrification also produces little sludge, because the nitrifying bacteria they produce and they also have to settle and those things. So, little sludge is produced in the process of denitrification as well. So, this is the kind of quantitative aspect, that per unit water treated, if it is treated from these different steps or the different processes. So, how much sludge will be produced that way. Now, if we see the quantity of sludge generated in different places, we do not have data from all the places available, but like report where the for various countries under the European Union, there is lot of sludge being generated from the wastewater treatment facilities. Okay. So, like you see in the 2010 there is from Belarus, it was of the order of 50,000 tons of dry solids per year. Okay. The Germany produces a huge amount of sludge. Okay. So, that is kind of 20 lakhs or 2 million tons of dry solids per year. Okay. Then there are Russia is producing around 1.8 lakhs, Sweden 2.5 lakhs, Poland 5.2 lakhs. So, that way significant amount of sludge is being produced from the different nations. Okay. Japan is facing sludge management problem. The collective sludge production from the your US, UK and China. China has a huge production of sludge which is not being managed properly. Okay. And same with in many other nations. So, if we see the total amount of sludge being produced from the like as we were saying, the China, US, UK, it actually exceeds over more than 2.5 million, more than actually 25 or 2.5 million tons per day. That is the order of magnitude at which the sludge is being produced. Okay. So that way, like the problem is huge of the sludge production, and there are various challenges in the sludge management. The sewage and industrial effluent sludge is becoming a serious problem due to high treatment cost and the risk to environmental and human health out of the sludge, okay, which is being produced. Further, the like if we say the case of India, as we discussed in the beginning, that almost 2/3 of the sewage which is being produced goes untreated. So that means lot of wastewater is not being treated at the first place, and when you start treating them, you will start getting more and more and more sludge. So what to do with that sludge, how to handle that? It requires a huge cost. There is a huge land footprint of the sludge management, there is a huge water footprint with the sludge management, there is energy requirement in terms of handling, in terms of transportation, in terms of dewatering processes. Okay. So that way there is a huge cost, huge environmental footprint and huge health risk involved in this. If you look at the major challenges, so few of the major challenges includes the stabilization of sludge. Okay. So sludge is not inert and can have an unpleasant odor. There are a lot of organic materials present in this, and it can turn to septic, it can lead to foul smell, those kind of thing, and can have various health impacts upon contact. So that is one of the major problems. Then we have the volume reduction, another major challenge, because as we were discussing just that the water content of the sludge is let us say for secondary treatment sludge is as high as 90%, 99%. Okay, the solid content is in the range of say 0.8 to 1.2%. So roughly you can say on an average value of around 1%. So that means 99% is the water, and you can imagine the quantity which is being generated. Okay. Similarly, from the primary sludge also there is more than 95% content is actually water. So there is a huge volume of the sludge is generated, and for reducing this volume we have to dewater that sludge, we have to take the or dry that sludge, we have to take that water out. So reducing the water content, again how we effectively can do that? If we leave it in the open, there is a large amount of land would be needed, and then what is happening to that water, untreated water, it will probably go to subsurface or those kind of thing. If we process it mechanically through centrifuges or those kind of things, so then there is a lot of energy aspect, energy cost associated with that. Okay. Then there is managing risk due to the organisms, various organisms and chemicals. So there are various risk causing organisms and chemicals could be present in the sludge, okay, which kind of can impose health risk. Then of course there is recovery of nutrients, nitrogen and phosphorus. So as we were just discussing, seeing the characteristic of the sludge has significant quantity or significant percentage of these fertilizing elements, nitrogen, phosphorus, potassium. So how we can recover those nutrients? Is it advisable to just like dump or decompose or put this to landfill, or don't use that, or if there is a means through which we can extract that, or we can actually kind of use that potential of the like fertilization of the sludge. So how we can achieve that, that's another major challenge. And then utilizing the energy potential. So the sludge has a lot of energy potential. We just saw that the undigested sludge, indigested sludge, they both have significant amount of energy potential. So how to utilize that energy potential? Okay. How we can extract the energy out of these systems, out of the sludge as a material, and then what fruitful application can that energy could be bring in, and whether the extraction of energy, whether the production of energy from the sludge is sustainable or not. Okay. So there is a lot of debate on that, on the energy production from the biosolids, on the energy production from the wastewater sludge. So, if you end up producing energy from the wastewater sludge, how much energy you have to supply first, because many times it has been seen that net energy footprint is actually negative. So, you end up supplying more energy than you are producing energy, okay, in order to just managing the solid. So, that kind of system cannot be recommended. So, we will have to like figure out that which are the possible approaches through which this potential of energy production can be applied, can be extracted or can be utilized in the most sustainable fashion. So, these are practically the major challenges, major issues with the sludge management or sludge handling. So, we will conclude this lecture here, and in the next class then we will start deliberating onto the approaches or methods of sludge treatment, sludge management and sludge handling. Thank you.